Hey, hi. So I have prepared this Google Colab. So with this, you can able to run the code in testing code in Google Colab. So what you have to do, you just have to go to the link which I have shared. Okay, make sure to create your own notebook. Okay, and copy this code block wise or execute this code block wise. Just go to this and then go to runtime, then click to change runtime and select GPU so that you will get a good performance. And then simple, you just have to run block one by one block. Make sure to run one by one block only, otherwise it will not work. Okay, then download this model, this encoder decoder model, and this tokenizer, and here is the code. So basically, this is the code for feature extraction. So with this, we are extracting the feature. I'll tell you about how what is feature extraction and why we are using everything. Just giving you the basic overview. And this is for model implementation, and this is for removing files from a folder. And then this is for let me run this. Okay, so simple, what you can do is either running one by one, you can directly go to run the time and you can select run all. That's it. It will run automatically one by one. It will take some time, but it will up in some time. Okay, and this is the code for prediction. Okay, and this is for live prediction code where we are uploading the file. So basically, see, for testing purpose, I have shared you some videos. If you go to your project folder and inside dataset, I have given you one some 25 videos of 64. There are some repeated videos inside this. Okay, so use these videos only while demonstration. What I suggest, now go to your Google Colab, choose these videos, do testing by your own. Okay, go to this project folder and upload those videos. Okay, upload those videos and check ki which one is working and which one is not working properly. Why? So that when you present to your faculty, so you know ki which video is giving good accuracy and which one is not. Because if you pass real time video, then it may not give accuracy. That's why I'm saying you. Okay, and basically I have renamed all the videos, so won't be able to get the uh, actual caption. So see, like, to check the caption, what you can do, you can just open these videos in VLC, Beaver, or any uh, anything. Okay, so what is this video is mentioning ki a woman is cooking something or like that. Okay, similarly, let me play some other video. What I suggest, just play those videos and check ki what should be like. A man is cutting something, right? A woman is cutting something. This might be a caption for the particular video. Okay, so let me upload the same video. So once everything will gets run, so you can upload the video by clicking on choose file. Then it will make the prediction. It will take some time because it is loading everything. So do this testing, okay, because that will be very helpful to you when you presenting the project. Okay, so first here it is extracting the feature, and then now it is making the prediction. Okay, I'll tell you okay, what is feature and how exactly it is working. Just be with me. Okay, so as you can see, a woman is cutting something, right? So a man is cutting. So in the video, it's the same case. Someone was cutting something and it was preparing, right? So caption is the same. It is not predicting ki what it is cutting, because in the caption it was not mentioned. Ki they have only mentioned ki a woman is cutting. So that's why it is showing like that. So similarly, what you can do, you can test some certain videos. Okay, and you can keep like the output is this one. Okay, so you can tell teacher ki actual output is a woman is cutting something. Okay, but the actual predicted caption is this one, so which is similar. Okay, 60-70% is similar. So this way you can do test and find videos with your own. Okay, I have given you some 64 videos which I have tested, and it is giving average accuracy on those videos. So do the same, okay, with you, so that you will have confidence. So So this is the code for the live detection. I'll share you this one. Okay, similarly to run the website, so same you have to do, you have to go to your project folder, and you just suppose this is my project folder. Okay, you just have to go to project folder, and then you have to go to this, you have to click this address bar. Here you have to type cmd, and after typing cmd you can type python app.py and hit enter. Okay, then it will automatically run the project. Basically, in the website I have mentioned image based captioning as well as video based captioning. Both captioning are there, so you can present anything. Okay, so yeah, it's up. So I just go to website, and then I have created some UI. Okay. So you can show this as well, so that because see, directly showing this, that is okay, but it don't seems like a final year project. Okay, so basically UI is always create a impact. Okay, क्योंकि जो दिखता है वो बिकता है, right? So that's why always having a UI user interface is a good thing. So that's why show this. So you can upload image, and then you can upload video, and it will process accordingly, right, as showing in demo. So yeah, so this is the way to run the website. Okay, so now let's come to the file structures and what exactly our algorithm is working. Okay, so basically, let me first go to the notebook file. Okay, notebook folder. So if you go to notebook folder, there are some two folders are there. Okay, video and image. And then if you go inside this, okay, then having training video model. Okay, so basically this is the notebook for which I prepared for training the video based model. Okay, so this is for downloading the data set. You can also run this, just upload into Google Colab and just execute one by one, it will automatically up. Okay, and so yeah, these are the lots of steps are involved. Okay, for training the file, I'll tell you one by one. Basically, first I'll tell you the data set, key which data set we have used. So we have basically used MS Video data set, which basically which is this is released by Microsoft, which you shared me, na, that's the same. Okay, just the only thing is I have downloaded directly, and you have shared some papers or something, right? So you have shared from Kaggle link, but I have downloaded with official link. Okay, so this is the same. Okay, so in the data set, actually I don't have data set right now because it's around 2 GB, so I have not downloaded, and number of files was lots of. So you can download. Okay, so basically, let me first I brief you ki what exactly our model is working. Okay, so basically, see what exactly a video is. Okay, and how our model is working, how it is making prediction on video. Okay, ki how it is generating. So first understand ki what is use of video based captioning. Okay, basically, see nowadays everything is video, right? If you see reels on YouTube, Instagram, or anywhere, right? Now the video is booming, right? It's a very trending nowadays. Initially the memes, we used to see memes and we enjoy that, right? But nowadays we used to see reels, right? We don't enjoy memes and images, we like videos, right? So videos captioning is something which is can be very helpful for the social media or any use cases, right? So because video is something which is like a quick way to understand anything, right? So uh, so video captioning should see, uh, suppose this is the video. Okay, so video is nothing but collection of images, collection of sequence of frames. It consists some hundreds or thousands of frames depending on duration, right? So basically, what we are doing, we are just taking a video, okay, and we are extracting 80 frames. Okay, we are not taking all the frames, because suppose there is some video which is around 50 GB, so it might having 800 or 8,000 of frames. So we can't take this because it will create a huge model, and it will create noisy data, and that will be won't helpful. Okay, because in the video the images is nothing but similar kind of images, right? If you see number of first frame and third frame, second frame, fifth frame will be same, right? So there is no meaning of taking repeated data. So that's why instead of taking all frames, we are just extracting 80 frames. Okay, from a video we are just extracting 80 frames. Okay, suppose this is a video, and what we are doing, we are extracting 80 frames. Suppose these are the 80 frames. Okay, and then we are passing these frames from ImageNet. Okay, so basically if you are aware, each image will be passed through ImageNet. ImageNet is a CNN model. Okay, so what is ImageNet? I think let me check whether it is ImageNet or VGG model. Let me check one second. There is a there is a file is there. Okay, get feature. Okay, so get feature is a file is something basically with helping to convert videos to frame. This is the function which converting the videos into frame, and it is also using to get the features. So we are using VGG 16 to get the features. So what is mean by feature? See, if you google it, VGG 16 feature extraction. So VGG is something which is helpful to extract the features. So what is features? So let's see in simple terms. So just consider this example. So this is the butterfly example, right? So how you got to know ki this is butterfly? Based on shape, right? Based on shape, based on number of color, based on their architecture, right? And flower. So these are the features, right? Based on this is called features. So based on this feature, we our mind understand anything, right? Similarly, VGC model help to identify the features. Okay, so whatever images we having, we are just passing those images through this VGG CNN model, and we are getting the features in the form of matrix. Okay, even if you see every image is nothing but a big matrix. Okay, what is image? Image is also a collection of pixels. See, video is collection of frames, a image is collection of pixels. Okay, and if you decode pixels as well, so pixels is nothing but a combination of three values RGB, it having a values of each color drop RGB, it will have the value. Okay, so in internally CPU having it is a huge matrix. It take as a picture. Okay, so picture is also numbers. Okay, just we are it is representing in the video, image format. Okay, so what CNN helping to convert this image into matrix of features. So basically this VGG model will convert 4 by something 4 by 49 something features, this number of arrays. Okay, of this particular image, and it will do for all. Okay, it will do for uh, all 80 images will be passed through this CNN BGG model, and it will convert a features matrix. Okay, and then what we are doing, then we are all the feature matrix which is converted by CNN, we are just combining everything, and we are getting 80 by this number of features. So every video is getting converted into this feature matrix, a big feature matrix. Okay, so this way we are extracting of features to understand the video caption in in this matrix format, and then we are just storing this matrix into a folder called feed folder. Okay, if you go to this data, testing data and feed. So if right now there is nothing, but when you run a project or any video na, so it will create one numpy file here. So this numpy is nothing but this matrix. Okay, so based on these features, we are just extracting this features. Okay, this matrix. So this file is basically helping to do the same. Okay, if you go to this Google Colab also now, so there is one extraction function is there. Okay, so if you check this, so yeah, this is the extraction function. So this is helping out to convert the video into frames, and this function helping out to get the combine the all 80 features. This function is helping out to kind of get the features with using VGG model, and here with this we are just storing into numpy file. Okay, here you can see the numpy file. So this way first we are getting the features. Okay, and then we are using encoder and decoder. Okay, so this way we are identifying the features, and then what we are doing, after this we have used encoder and decoder format. Okay, so what is encoder and decoder? Okay, uh, see, I suggest do some research with your end as well. Ki what is encoder and decoder, because I have a rough idea ki what exactly it is working. It is nothing but language uh, trans like converting. Okay, so basically, as you can understand, right, encoder and decoder. Encoder is nothing but to help to encode the data. Okay, and decoder is used to decode the data, right? So now what exactly it will decode and what exactly it encode? Okay, so basically we have used LSTM algorithm in encoder. Okay, if you go to the uh, part, okay, inflation part. Okay, so this is the decoder input and this is the encoder. So basically here I am loading from JSON file. So it let me go to training file. There we can see the proper encoder decoder architecture. So basically this feature extraction almost take 1 day to convert all the features to video features. So if you run this notebook in Google Colab, then it will take 1 or 2 days to convert the features. Okay, uh, so the encoder part, just a second, this is the decoder part. Okay, where is the encoder part? Yeah, here is. So this is the encoder part. So in the encoder part, we are using 80 number of LSTM nodes. So what we are doing, so how exactly LSTM work? LSTM is make prediction. Basically, it hold memory, hold the data, and based on previous data and next data, it makes the prediction. Okay. So what we are doing, we are created 80 nodes in the LSTM layer. Okay, and we are just passing all the all the data. We have extracted 80 frames, right, and we are just storing all the frames features in this encoder. Okay, in the LSTM encoder we are just storing these frames features, frame matrix, okay, inside this LSTM encoder. Okay, similarly in the decoder we are just respective, like whatever respect to caption is there, we are just storing each and every word from start to end. We are just starting from LSTM 18 nodes are there, right, and ending with last 81. So between 2 to 79 we are just storing the caption, whatever caption is available for this video, we are just storing that. Okay, and if I tell you, so tell you the example training data, this is a training sample. So see, so basically what is a video, suppose this is the video. So in data set, a single video having multiple captions. Okay, so these are the captions, right? So what we are doing, we are just storing all these captions into this nodes, into this 80 nodes. Okay, unique words. So we are just encoding the frames, and when we are using decoder to decode that particular to like combine both the things. So this way, like each video having number of basically the video which I have given, I don't remember the IDs, so that's why won't be able to tell you the exact caption, what was the exact caption, because I removed the ID's name from the dataset video. That's why. So you can just play the video, and you can also get the caption, okay, by your own. So what we are doing, so as I told you, okay, we are just decoding decoder, we are just storing the words. So this way we are just storing the word and encoder and decoder. Then we are training the model, okay, and then we are combining encoder, decoder, and this image net, and then we are making a single model and training it. Okay. So if you go to this notebook folder, let me go it. So here you can see. So this is the video description class where I have defined some parameter, required parameter, and this tokenizer. Tokenizer is nothing but it will convert. Similarly, see, tokenizer. Similarly, we are just converting frames into array, right? Into feature number of it. Basically, see, if we directly pass a frame or video to algorithm, then algorithm don't be able to understand anything. It don't know what is a video, what is image, right? So that's why we are converting into array. Similarly, if you pass sentence or caption or text directly to algorithm then algorithm won't be able to understand what you are passing. Okay, so we have to perform tokenizer. So what exactly in simple term tokenizer do? It will assign a unique id to each word. Okay, see, whatever captions we having will having a different words, right? Suppose is a word, woman is a word, right? Man is a word. So in the caption list we having n number of words. So what tokenizer will do, we will be passing these words into tokenizer algorithm, and algorithm will assign a unique value, like it will assign a as a 1000 or something, a woman as a 2000, man as a 3000, so that we can use same id, we can use these IDs to encode these particular words, and while decoding we'll use the same tokenizer and we'll pass the ID and it will give a output text. So this way, tokenizer is working. Do some your research as well, okay? And here we are doing the pre-processing. Pre-processing means we are just loading the caption list, and then we are just shuffling, and then we are performing tokenizer in the captions, and then we are checking key is the numpy values are available or not. If it is not, then it will throw error, and then we are checking loading the data set. Okay, so here we have defined the you know we are just I told you, right, key, we are just passing the frames into the encoder and decoder. So we are doing the same key, we are just taking one by one input and the frames and just passing into encoder and decoder to encode and decode. And this is the train model where we are defined actual architecture. This is the encoder architecture, this is the decoder architecture, this is the combining, and here then we are loading, and then we are compiling the model, and then we are created the checkpoint to save the model, and then we are fitting means training the algorithm, and then we are just saving the trained model. So this way we are training the algorithm, and it has trained 100 epochs and we have got around 70% accuracy. Okay, still it is uh, not it's good for video captioning, because video captioning is very difficult task. Okay, so this way we have trained the model and we have used the architecture, and for building front end. Okay, so we have utilized flask framework. Okay, so what is flask framework? In front end we have simple use html css, simple html css. Okay, and for backend we have used python language, right? And python is responsible for machine learning code validation and everything. html is responsible for displaying the markup language. Okay, but we need some middleware or of some framework to connect front end and back end. So for connecting front end back end we have used flask framework. Okay, so for the flask framework we have to define the controller. So what exactly controller do? See, if I run my project, say this is the app.py. So the app.py basically a controller file, okay, where we have to define the roots. Roots means, see, I have defined some roots, right? What happened? Uh, Let me run it again. Yeah. So as you can see, there are some routes are available, like home route. In the home route, we are displaying index.html page. About us route is there, where we are displaying about us HTML page. So these routes we have to define. Like when user come to this route, so what we have to do? Suppose currently there is no route, right? It's slash. So if you go up, so there is a slash mention method is defined. Here it is the index file. So what we are doing here, we are just displaying the index.html file, which is the main file. So if we go to this flask, so here this is the index.html file. Similarly, if you click to login button, then here you can see it got changed to login root. So then cursor will come here and it will check where is the login root. So login root is here, and then it will check what we have to do. Then we are saying display login.html file. So like this flask working. Okay, and yeah, so yeah, this is the technical part. Do let me know in case of any issue. And for image based we have used Flickr dataset. Okay, Flickr 4K or something dataset we have used. 8K Flickr 8K. Okay, and if you go to this notebook file, and if you go to image section, you can show this image thing as well. So your sir will like get impressed कि you have done both the thing. So this is the data set which we have used, and here we are doing the same key. We are just loading and unzipping the data, and then we are just checking the caption. And they have also provided description text where they have mentioned the all captions, and then we are just cleaning the caption. And here also we are doing the captioning tokenizer, and we are just mentioning start and end point. Similarly, this is the process image function to process the image, and this is for encoding to get the features. Means which similarly, like I shared you right here we have used ResNet 50 model to get the features, okay, of input image. And then if you go down uh, here, so this is the feature model which helping to get out the features. And this is the embedding model where we are just encoding the caption with the frames. So then we are just like that we are doing, okay. So I think it's not your project, but yeah, still if you want show, then you can show this as well. So this way you can show this image part as well, okay. Okay. So yeah, do let me know in case any doubt or any issue. Okay. Thank you. I'll share you this. Okay. If you face any issue with this while running it, do let me know. Okay.
Thank you friends for watching my video. If any, then subscribe channel and share with a friend. Thank you.